Hey everyone, welcome back to your physics buddy. In our last lecture, we learned how to simplify circuits using series and parallel rules. But what happens when a circuit is too complex to just collapse into one resistor? This is exactly what we are solving today. Welcome to the lecture 2 of Unit 11. Today we are mastering Kirchhoff's law. We are breaking down the junction rule and loop rule, the two fundamental tools that allow us to solve for current and voltage in any circuit, no matter how messy it looks. Remember, these laws aren't just random maths, they are actually the conservation of charge and energy in action. If you are still feeling unsure about basics of V is equals to IR from our first lecture, make sure to go back and watch that one first to
In
keep
today's
your
session,
foundation
we're going to
strong.
talk about different types of circuit, like what kind of circuits we have, how these circuits can be resolved, and what are the rules that are needed to be solved these circuits. We're going to understand all of
Okay.
them in today's session. So, first of all, you have to understand that what circuits exactly looks like. Like for example, we try to explain the different types of circuits. The circuits can be categorized in two basic categories. First is going to be simple circuits. Simple circuits are those circuits which has only one loop, whereas another such type of circuit is called multi-loop circuit. So as the name suggests, if there are more than one loop in a circuit, that is simply known as multi-loop circuit. So, so far, what we were doing in the previous session is that we were trying to convert a multi-loop circuit into a simple circuit by simply classifying that how resistors are connected in series and parallel. But there are few cases in which we cannot connect those resistors in series and parallel and analyze it accordingly and convert it into simple circuits or a single loop circuit. Like for example, suppose there is a circuit. So this is one such type of circuit in which there are three batteries connected having different potential. Along with it, there is different resistors as well. So as you can see here, these resistors will not be categorized either in series combination or in parallel combination. So what we are going to do is we are going to consider them as a multi-loop circuit. So in order to solve multi-loop circuits, we have two rules, and these two rules are very important, like they are hell important. And these rules are generally known as Kirchhoff's rules. So Kirchhoff's is again a scientist, again a physicist who gave these rules to solve the unknowns in any given type of circuit. So what we have to understand here is that this is going to be a very general approach in solving these kind of circuits, which are referred as multi-loop circuits. In these circuits, we cannot convert them into single circuit, or you can say simpler ones. So we have to solve them by using Kirchhoff's rule. So in order to understand what are Kirchhoff's rules, we need to understand few things about the circuits. The first very important thing is, so basically a point where there are two or more wires are joined, like this particular point or this particular point. These points are generally referred as nodes, or apart from nodes, we can also call them as junctions. The first rule we have is known as junction rule. So it's a pretty simple rule. So junction rule says that sum of all the values of current along a circuit, along a junction is zero. Like, what does it mean? Let us try to understand it through statements as well. So, junction rule states that the algebraic sum of the current at any junction is zero. What does it mean? It simply means, suppose there is a junction having so many wires connected to it, like that. And what we observe here is that there is a different values of current in each wire. So what this rule says is that whatever current coming into the circuit or coming to the junction or the node, like this P is a junction, I can say here. So whatever current is coming to the circuit, coming to the junction, must be equals to whatever current leaving the junction. What does it mean? It simply means that I1 plus I2, as it is coming to the junction, must be equals to I3 plus I4 plus I5. Or here you can also say that whatever current coming to the junction minus whatever current leaving the junction is always equals to 0. And from here we got this particular equation. So let us try to understand that how this rule can be simply applied in a given circuit. So I'm just assuming one circuit. The circuit looks like that. So this circuit has so many components. What we are going to do is we're going to find out that how current is going to get divided. So assuming this is the V1 potential, this is V2 potential, and all the resistors are supposed to be R1, R2, R3, R4, and R5. Now, what you have to understand here is that whenever there is a current in a circuit, it must be coming out from a battery. And if you understand this fact, suppose we have a battery. So whenever there is a battery, it is represented by this particular symbol. And this bigger plate or this bigger line is actually representing the positive potential of the battery, whereas the smaller plate is representing the negative potential of the battery. So current always comes out from the positive plate. Current always comes out from the positive plate and enters into the battery from negative plate. So this is how current came out of a battery. This is also we need to understand. So if this is a battery and this is again a battery, so current must be coming out of this battery from the positive side. So I can assume that there must be some current I1 coming out from here and there must be some current I2 coming out from here. Now what we have to understand is you have to understand that how junction rule can be applied onto the different junctions in this given circuit. So let me just assume this is my first junction. This is going to be my second junction, third junction, and fourth junction. So there are four junctions, or you can say nodes. We'll try to analyze that how current is being passing through these junctions. So just try to understand each and every part very patiently. So here I can say that I1 current is coming from the V1 battery. So this I1 current will come till here. Now as I1 current comes till here, at this particular point, it becomes I1 plus I2. Why? By applying simply a junction rule. Like whatever current is coming into the circuit must be equals to whatever current is going out of it. So what I can assume here is that there is some current that must be going out from this particular junction 1. So I can say at junction 1, current whatever is going outside must be equals to whatever current is coming into the junction. So this is current leaving junction, whereas I1 plus I2 is the current coming into the junction. So current coming towards junction. So this is how you are supposed to apply this particular rule. Very simple one. There is nothing like difficult to understand also. Similarly, let's try to analyze this thing again for another junction, that is junction 2. So this current will come here. I assume that this is I1. So now what is going to happen here is this current, as this junction 2 is there, so this current will going to divide into two parts because there are two wires coming from this particular point. So I can assume that current went here is something I3 and that it went here is something I4. So whatever this I1, I3 and I4 come to this junction 3, it again going to become this value I. So as this I reaches till junction 4, it must get divided. Divided in what sense? Dividing I2 and I1. So this is how we are supposed to see that how junction rule is being applied. So we are just keeping it very simple. We are simply assuming that how everything is going there. So always remember how we are supposed to solve and apply junction rule. Another rule we have here is known as loop rule. So this is also known as Kirchhoff's loop rule. This Kirchhoff's loop rule tells almost similar but a different thing. It says that sum of the potential across a given circuit is always zero for a closed loop. So it simply says that sum of voltages around a closed loop is zero. Now, how we are supposed to apply this? This is the most trickiest thing, and if you got to understand that how this particular rule is applied, you can easily solve any difficult to difficult loop, or you can say multi loops problem. So we'll try to do that also. But before that, let us define that what this law says. So according to this law, it states that the algebraic sum of the potential difference that is voltage across all of the elements, like whatever element is there of any closed loop, and the loop is supposed to be closed, is zero. So let me just let you understand that how we're supposed to apply this particular equation in a given circuit. I'm taking another very simple example. So just try to understand that how the thing is going on. A very simple question, I'm assuming, and this will help you to understand this thing. So the loop looks like this. It's a very simple and basic one. So this is the potential battery, and there are few resistors R1, R2, and R3 connected in a circuit. The value of each and every resistor is given here. Let me just give you the values. So R1 is supposed to be 6 ohms, R2 is supposed to be 3 ohms, R3 is supposed to be 10 ohms, and the potential of the battery is supposed to be 12 volts. The question says which resistor will carry the most current. So basically, which resistor will be having more current passing through it? This is the first thing we have to answer. Also, we have to tell that what is the current and voltage across each resistor as well. So there are different ways of doing this problem, but we'll try to understand this by using Kirchhoff's law. Try to understand this thing very carefully. So question is find current through each resistor and potential difference as well. So as we understood how Ohm's law can be applied in the previous session, so we can apply that also. Let us try to solve it using that first. So according to Ohm's law, V is equals to IR. So first of all, we'll try to find out the net current coming out of the battery. That is, let's say I. So I must be equals to potential over R, and this R should be R net. So in this case, what is this R net going to be? So as we know that R1 and R2 are in parallel combination, so we can simply solve these two resistors first to get R net, and this will give us around R net as 6 over 3, that is 2 ohms. Now this 2 ohms resistor is connected in series with 10 ohm resistor. So the net resistance of the circuit is going to be 2 plus 10, that is 12 ohms. As the potential is 12, net resistance is 12, so we got the value as 1 amperes for this current. So the battery must be releasing this 1 amperes of current only into this given circuit. So we got the value of I here Now, what we need to understand is we need to understand that how potential is going to divide across these two things. Like here, there must be some potential drop, I can say V1, and there must be some potential drop across, I can say V2. So if we want to find the value of V1, what we can do? We can simply write it is going to be I1 R net. Now this I1 is nothing but this I only, because the net current passing through this particular section is going to be I, which is 1 ampere. So V1 must be equals to I1, which is 1, R net, which we just found as 2. So potential across this particular resistors is going to be 2 volts. So across R1 and R2, the potential is going to be 2 volts. Similarly, if we have to find the net potential across this R3 resistor, so we have marked it as V2, it must be equals to I times R. I is 1 and R is 10, so potential is going to be 10 volts. Also, we need to understand this fact that whatever potential is there, the sum of these two potential must be equals to individual potential. So V1 and V2 must constitute the 12 volts potential, and we can simply see here that we can calculate it this way. So I hope you understand this thing. But similarly, we are we can also find out the same thing using Kirchhoff's rule. So let us try to understand that also. Why? Because in some questions you might not be able to apply Ohm's law directly. So we need to understand, or we need to have the basic knowledge of Kirchhoff's law in order to solve these particular kind of questions. So let us do with another approach of Kirchhoff's law, and whatever you find easy in a given question, you can apply. So always remember this particular thing, that you can apply whichever way you find easy depending upon the given circuit. So let us write the values of each and everything once again. So this is the circuit, and we have to solve this using Kirchhoff's law, or you can say which is our second method of solving this particular circuit. So how can we do this? First thing we have here is there are two rules. The first is loop rule, and second is junction rule. So let us try to form the equation using junction rule. The junction rule says if there is some current coming out of the battery, at reaching junction, it must divide into depending upon the value of resistor. So I can assume that this is going to be I1, this is going to be I2, and whatever coming out, whatever coming is coming from this battery is I. So I can simply write using junction rule that I must be equals to I1 plus I2, or I can say I minus I1 plus I2 must be equals to 0. Does this make sense? Tell
Yeah,
me.
kind of.
Similarly, we have to apply the second rule, and the second rule says the sum of all the potentials must be equals to 0. So how we can actually find out sum of all the potentials? This is the most important part we have to understand here. So in order to do this, we have to actually form a loop. We have to actually name a loop. How we are supposed to name this? So I'm marking this point as A, this as B, this as C, this point as D, this as E, F, G, and this point as H. So just try to visualize this thing. In loop, read it well. In loop A, B, C, D, E, F, G. So which rule I'm talking about? I'm talking about this particular loop. Got it?
Okay.
Basically, I'm going to consider whatever components are there in the circuit across this loop. Similarly, there is another loop which is, I can say, as A, B, C, H, E, F, G, again A. So in that case, I have considered 6 ohm resistor. So these are the two loops. So in order to apply the second law, or you can say the loop rule, we need to actually first of all select the loops, that how loops are being selected. So here, first I'm taking A, B, C, D, E, F, G loop. So in this loop, we have to read each and every arm, like A to B, B to C, C to D, D to E, E to F, F to G, G to A. We have to analyze each and every arm. How we are supposed to do that, let us understand. So again, whatever circuit you have, first of all, you have to choose the direction of reading a circuit. The direction of reading a circuit, it can be clockwise or it can be anti-clockwise. It completely depends upon you which direction you need to choose. Whatever direction you want, you can choose. But what I suggest is always choose a direction in which the battery is connected. So current is coming out from the battery in clockwise sense. So the direction which I am going to choose, again, it is going to be clockwise like that. Why it is good to choose that direction? Because this will help in calculation a little. It will make calculation a little easier. The sign or the confusion is like being dropped from this particular thing. So this is how we're supposed to choose the direction. So whatever direction you have chosen, you also have to mention the same direction using the loop. Like for example, I have written A, B, C, D, E, F. It automatically says that I have chosen clockwise direction. Similarly, if I write this loop as A, G, F, E, D, C, B, what does it mean? It means anti-clockwise. So this is the most important thing. First of all, we have to learn here that what these loops says and how we are supposed to write these loops. So these both of these things almost similar but very different as when it comes to the direction sense. So this direction is actually of the direction of reading the loop. That's how we are actually reading the loop. So let us see how we are supposed to read it. So from A to B there is nothing. From B to C again there is nothing. From C, D, E there is one resistor. And from this resistor I can say this current I1 is passing. So whatever potential is there, I can write it as some V1 potential, let's say. So I'm marking it as V1 potential. So I can say as the current is flowing in the same direction in which I am reading the circuit. Again, listen to it very carefully. As the current is going into the circuit, the same way I am reading the circuit. So I will take this potential as positive. This is the sign convention and the most important sign convention. So I'm taking it as positive V1. Now, as this I1 current is coming through 3 ohms resistor at point E, the current again changes to I because I1 and I2 will definitely add up and this will give us this I only. So now what we can say here is that potential across 10 ohm resistor is going to be something V2. I'm assuming it. Again, my direction of choosing is equals to the direction is same as that of direction of current. So I'll take it as plus V1 plus V2 like that. Now what we can write here is the sum of the potential across the different elements in a given circuit must be equals to the external potential of this circuit, that is 12 volts. Now try to understand how we can write these values. This is the most important section. So I can say V must be equals to V1 plus V2. Now what is the value of V1? We just try to understand it. The value of V1 is going to be I times 3. This is what Ohm's law says, right? So we are going to apply the same again, but as per the rule. So it is going to be I1 times 3. So I can write it as 3I1 plus V2 is going to be what? V2 is going to be 10 times I. So I can write it as 10I. Always remember I1, I, they both are different. And the V is what? 12 volts. So 12 volts is equals to 3 times I1 plus 10 times I. So this is my first equation. And first equation for which loop? For this loop. A, B, C, D, E, F, G. Again, this equation came from this particular loop. Whatever things I have told you, just keep those things in mind. Similarly, if I take loop, the different one, A, D, C, H, E, F, G, this one. So in this loop, again, the direction is defined. I'm taking a clockwise direction, so I'll be reading the circuit in a clockwise sense. As per the rule, sum of all the potential must be equals to 0. So now try to understand this thing once again. I'm taking the loop ABC. ABC has no component, so CFCHE has some component. So I can mark it as V3 potential. And this is already defined. The potential across 10 ohm resistor, it is V2. So what can I say here is that V must be equals to V3 plus V2. Like that. Similarly, V is 12. V3 is what? V3 is 6 times I2. Whereas V1 is what? V2 is what? V2 is 10 times I. So here we got two equations. And apart from this, another equation we have is the equation of current. Once we solve these three equations, we can have the value of I1, I2, V1, V2, whatever values we want. Does the thing make sense? Are you able to understand it? How we are
Yeah,
forming the equations?
kind of. Yeah.
Although we'll do some problems and this will be crystal clear. So let us try to solve these equations. First of all, let's write what equations we got. So we got 12 is equals to 3I1 plus 10I. Similarly, apart from this, we got equation 12 is equals to 6I2 plus 10I. Apart from this, we got another equation which says that I is equals to I1 plus I2. So what we are going to do here is we are going to substitute the value of I in both the equations one by one. Once we do the substitution, we got the equation in two variable. We can solve that equation. We already know how to solve those two equations. So the thing is going to be 12 is equals to 3I1 plus 10 I1 plus I2. That is going to be 12 plus 3I plus 10 I1 plus 10 I2. That is going to be 10 I2 plus 13 I1. This is my another equation. I can mark it as third one. Apart from this, I have to solve the another equation as well. So 12 is equals to 6I2 plus 10I1 plus 10I2. I'm writing it directly now. So 12 must be equals to 10I1 plus 16I2. This is going to be my fourth equation. So now these two equations are equations in two variable, and we know how to solve these two equations either using elimination or substitution, whichever method you find it easy. You can use and solve. But remember, these equations can be solved, and we'll got to have the value of I1 and I2. Once you got the value of I1 and I2, we are good to go. So let us try to solve this equation and see what's the value of I1 and I2 we are having. So in the last case, this one, we didn't find the value of I1 and I2. We just find the net value of current. Although we can try finding out the value of I1 and I2 as well using these two equations by simply solving them. So any idea how we're supposed to solve these equations? Simplest way here I can see to solve these two equations, we need to simply convert one equation into another. Like one variable must have the same coefficients in order to be solved. So what do you think? How can we solve this? Let me just try to reduce this equation a little. So we get 6 is equals to 5I1 plus 16I2. It is going to be 5I1 and it is going to be 8I2. We cannot reduce it further. So in place of this, we can write this one. Now, in order to eliminate any of the given variable, that is I1 and I2, we need to either multiply the same with some number, or we have to think of something else. So tell me, what are we supposed to do? How can we solve this equation? Did you ever solve these two equations?
No.
Obviously you have. It's not possible. You came here without solving these equations. What is the elimination method? Tell me.
Uh, we can uh, we can multiply both equations by a same uh, multiplier and get the same value for both.
Not a same multiplier, but a different multiplier to get the same value of any of the
Yeah.
coefficients of any variable. So let me just do it by considering this particular part. I'm multiplying this equation by 8 and multiplying this equation by 10. So let's see what we get. So 8 times 12 is going to be 96. It is equals to 80I2. And 13 times 8 is nearly 1, 104I1. Whereas this is going to be 60, again 80I2 plus 50I1. Once we solve this equation, by simply subtracting them. So this is going to be cancelled out. We got 36 here, we got 54 here. So I1 must be equals to 36 over 54, which is equals to 6 over 9, which is equals to 2 over 3 amperes. This is how we are supposed to find out I1. Now we simply substitute the value of I1 in any of the equation we have found so far, and we can get the value of I2 as well. So let me just put it in this equation. So 6 is equals to 5 I1, that is 2 by 3 plus 8 I2. Once we solve this, 6 minus 10 over 3 must be 8 I2. So it must be equals to 18 minus 10, that is 8 over 3 into 1 over 8. This is the value of I2. So I2 is going to be 1 by 3. So as we already know, the sum of these two values must be equals to I1 plus I2. So 2 by 3 plus 1 by 3, it is equals to nothing but 1. So as you can see here, the sum of the values of current we got here from this particular part also, method also 1. And earlier on also, when we solved using Ohm's law, we got the value same. We got the same value. Now what you can infer from this particular part is that either using Ohm's law and either using Kirchhoff's law, we can solve any of the given circuit. Why we need to understand Kirchhoff's law? Because sometimes the circuit which we are going to have is not the simpler one. This is going to be a multi-loop circuit, and in those circuits you cannot apply Ohm's law directly. So we have to apply these laws. Let us do one more problem, and this will let you understand that how this thing can be solved. All you need to understand is how the loops are being there, how we are supposed to have those variables, and what exactly we need to find. This is the most important part. You need to understand that what you need to find. So I'm taking a very simple circuit as of now. Try to find out the given value. So the question says that circuit looks like that. So the circuit we have, it looks like this. It is having a combination of resistors, it's having a combination of batteries, and the value of each component is given. This battery is 20 volts, this battery is 10 volts, this resistor is 5 ohms, this resistor is 4 ohms, this is 6 ohms, this is 2 ohms, 2 ohms, and 2 ohms. The question is find the current in each branch. So we have to find current in each branch. Let us see how can we solve this particular problem. Again, a very important question. If you understand this particular part, it is very easier to go with it. So in order to find out current in each branch, can we do this circuit like a little bit simpler? Can we just simplify the circuit a little? I guess yes, we can. What we can do is, first of all, we can solve these three resistors as they are connected in such a way that we can see that it is a parallel combination. Apart from this also, these two resistors can also be resolved. How can we do that? Just try to understand it well. So the combination of these three resistors in parallel is going to be 1 over Rp. It is equals to 1 over 2 plus 1 over 2 plus 1 over 2. It is going to be 3 over 2. So Rp is going to be 2 by 3. That you can simply infer. So we got the value of net resistance here. Now just try to observe this particular part. So as this is connected to a battery like that, can I just consider that 6 ohm is connected here like that? Will it change the configuration of circuit in any sense? No, it is not going to do that. So you can consider this 6 ohms connected this way, parallel to 4 ohms. How we can infer whether it is parallel combination or not? By simply looking at the value of current. So whatever current is coming into the circuit, it must be dividing at this particular junction. If it is dividing at this particular junction and the current passing through them or you can say the potential must be same for both the resistors. So they must be connected in parallel combination. Now we have to find the net of these two also. So I can say I, or yes, I would say R net in this case is something which is 1 upon RP must be equals to 1 upon 4 plus 1 upon 6. Once we solve this, we'll have 24 here, 6 plus 4, that is 10 by 24. So RP is going to be 24 by 10, which is approximately, I guess, say 12 over 5 ohms. So we got the value of this also. Now, the thing has changed a little. We modified the circuit. Let us draw the new circuit or the different one. So here we got one resistor. And here we got another resistor. Because we have simplified the resistors here. So this resistor we got here is 2 by 3 ohms. Similarly, the resistor we got here is 12 by 5 ohms. And the resistor in the middle is of 5 ohms. Whereas this is 20 volts, this is 10 volts. So now this is how the circuit looks like. Again, you cannot solve this circuit using Ohm's law, so you have to solve using Kirchhoff's rules. So in order to apply Kirchhoff's rules, we have to first of all give the name of the loop. So I'm considering it as A, B, C, D, E, and F. Now first of all, we will apply the first rule, that is junction rule. The junction rule says that sum of all the current at a given junction must be equals to 0. So which junction we can see here? So here we have two junctions, one is B and another is E. So whichever junction is closer to the battery, you have to apply junction rule at that junction. So as you can see, this is 20-volt battery, this is 10-volt battery, so the current must be coming towards the junction from these two batteries. Again, remember the positive part. Whatever positive plate we have, the current is going, or you can say current is coming out of that positive plate. So I can consider it as I1, it as I2. So these two current will add up and some I current will pass through this 5 ohm resistor. Once this I current reaches the E point of the junction, this is again going to get split and it will split into the same ratio the way it enters. So I1 and I2, it must divide in that way only. So this is how you are supposed to first of all apply the first rule in order to see that how current is actually changing or how current is actually there in the circuit. Did you understand this part?
Yeah, kind of.
Now in loops, we have to apply the second rule, which is called loop rule. So just tell me, how many variables do we have here as of now? How many things we can actually find here? What are the variables we have here?
Uh,
Tell me.
I1, I2, and I.
Exactly. So here we have three variables, and as we know, in order to solve any problem having more than one or two variable, you need to have that much number of equations. So if there are three variables, we need at least three equations. So can you spot any three loops which you can see and apply loop rule here? Give me the names in terms of ABC.
A, B, A, B, E.
Name the complete name the loop completely.
Okay, so A, B, C, D, E, F.
All right. So first loop we'll have here is as per you A, B, C, D, E, F. So it must be like that, right? What about other? Because we need three loops at least to find three equations, then only we can have this equation solved. So first of all, just tell me the value of the equation, or just first of all tell me the equation using junction rule at point B. What should be the equation through junction rule we got for the current? as per this?
Uh, V equals 5I.
No, no, no. I'm asking you what is the equation of the junction rule? Like this one, summation of all I must be 0. Just try to remember what we applied here at this particular junction C. Whatever current coming to the point must be equal to sum of the current leaving the junction. So just apply the same here also. What is the current coming to this point? What current is coming to the junction?
20, 30 volts.
Current. Current is I1 and I2.
Yeah.
So I can say I1 plus I2 must be equal to the current leaving the junction. So what
Okay.
is the current leaving the junction is I. So this is my first equation using junction rule.
Okay.
Now, how many loops is possible in this situation? The first loop you have already told. The second loop we have here is going to be A, B, E, F, A. Similarly, the third loop we have here is B, C, D, E, B. So now this is kind of clear that the loop we have chosen, they look like that. Now, out of these three loops, we can use any of the two loops to find the two equations because we got the one equation already. So we need to use any of the three, any of the two loops out of these three to find out the equation. How can we do so? Let us do this. So let me just choose this loop A, B, E, F, A first. So in loop A, B, E, F, A. First of all, we'll read A to B. A to B is having only 20 volts battery. As it is having only 20 volts battery, so it is going to be 20. But we have to see the direction also. We are reading the circuit from A to B and battery is also connected from A to B. So it is going to be positive 20. This positive 20 must be equals to whatever potential is there across this 5 ohm resistor plus whatever potential is there across this 2 by 3 ohm resistor. So we can mark it as, we can assume that it must have some potential V1, it must have some potential V2, so it is 20 must be equals to V1 plus V2, like that, as simple as that. Now what is the value of this V1? V1 is going to be I times 5 plus what is the value of V2? V2 is going to be I1 times 2 by 3. So here we got the first equation which is having variable I and I1. Similarly, we'll use another loop. So I can say in loop, as we have chosen B, C, D, E, B. So you need to understand that whatever we have choose is starting from B. So just try to understand now how the equation is written. As we are going from B to C, but current is coming from C to B, the value of potential will become negative 10. This is the sign convention. Now this battery, this must have some potential V3. So I can say it is going to be V3 plus V1. Why? Because BC wire has 10 volt battery, CD wire has 2 by 12 by 5 ohm resistor, DE has nothing, and EB has V1 potential. Now what you need to understand the sign convention once again. This V1 is going to be negative V1. Why? Because we are reading the circuit from E to B and current is heading from B to E. So this is the thing and this makes the value negative. So ultimately we'll have here minus 10 is equals to V3. V3 is what? Again, V3 is going to be negative. Why negative? Because we are reading the circuit from C to D and current is flowing from D to C like that. So it is going to be I2 times 12 by 5, that too of negative. Again, V1 is going to be I times 5, but again of negative value. So we got the second equation now. These two equations need to be resolved by again substituting the value of this. I1 plus I2 is I, so we'll substitute the value of I here and we got the equation in I1 and I2 time I1 and I2 terms. Let us solve this. So 20 is equals to 5I is plus 2 by 3 I1. So I is what? It is I1 plus I2. So I can write it as this. So 20 must be equals to I1 5 plus 2 by 3 plus 5 I2. Once we solve this, we get 17 I1 by 3 plus 5 I2. This is my third equation, which is needed to be solved. Similarly, the second equation we have here is minus 10, and I'm just taking minus common from both the sides and just putting cancelling around. So 10 is equals to 12 by 5 I2 plus 5 I. So 12 by 5 I2 plus 5 I1 plus 5 I2 must be equals to 12 by 5 plus 5 plus 5 I1. So I2 must be equals to 5 times 5 is 25, 25 plus 12, 37 by 5 plus 5 I1. Again, remember, this is very important to solve these equations correctly, and mathematically they should be correct. If they are not, it is not going to be, we are not going to get a good or clear answer. Also, the thing you need to remember here is the answers which you are getting for I1, I2 and whatever variables you are solving, they are not the simpler one. They must be in a very bad fraction, you can say, or you might feel it is like a little unrealistic. But trust me, you just need to consider, you just need to confident about your concept which you have learned, and then only you will be able to solve them. So you
Okay.
got these two questions. You can apply the same rule which we just applied in the previous question, and you can solve and get the value of I1 and I2 which is required. Similarly, you also get the value of I. So this is the rule. This is the way to solve these problems, and your book has a lot of problems. You can try those problems, and if you have any doubt in any question, just let me know. We'll discuss it as soon as possible.
Okay.
So let's keep it till here only. See you in the next class.